Welcome back! It's another exciting episode of How to Do Stuff with Mr. Stevenson. I did take a little time off. We went back to full-time school way back in those days. And so I've been, teaching normally and got a little lazy on making videos, but I'm back. Make sure they all get on and I will add even more. And I'm excited about it. So, without further ado, let's start with proportional relationship. Anyway, the word proportion shows up in there. A proportion. What is a proportion? Basically, if you look at this table right over here, a proportion is basically ratios that are equivalent. So, for example, I have a table of numbers right here where we said something like the days traveled and the number of times filled for gas. So if you traveled for 2 days and you filled gas 3 times, you traveled 6 days and you filled gas 9 times. So the ratio, my pen here, the ratio is a 2 to 3 ratio, which is the same thing as a 6 to 9 ratio. So those would be considered proportional. Just equivalent ratios. 2 to 3 is equal to 6 to 9. If I multiply each of these, this by 3 I get 6, and if I multiply this by 3 I get 9. And if I keep multiplying 2 to 3 by the same number, I'm going to get all the different ratios that are equivalent to 2 to 3, and that's called, and those are all proportional. Okay? So that's what proportions mean. Alright, so in a table of numbers here, it's pretty simple. So what you're going to do here is you're going to just fill in the table and look at what you're multiplying by. So to get from 2 days to 6 days, you multiply by 3. But how do you get from 6 to 10? You don't have to go from 6 to 10. Instead, you could go from 2 to 10. Because you'd multiply 2 times 3 to make 6, but you'd multiply 2 times 5 to make 10. So that's called scaling up. We talked about that in previous lessons. So if I took 2 times 3 to get 6, you'd take 3 times 3 to get 9. So I'd get times 3 here, that down, times 3, times 3, right? And then with the red arc, that's times 5. And I have to take this times 5, just like in fractions. Arrow on that. Okay, so that would be times 5, from 3 to 15. No problem. So what if we added our own number in there? What if we said this? Let's say you traveled 18 days. Okay, well we can scale up from 2 times 9, or we can scale up, say, times 3. And we'll do times 3 here. And you'd get 27. So those are proportions. That's how you use tables to find proportions. And of course, you can also multiply across. We'll come back to that. Okay, so that's one way. It's just filling in a table of numbers. In equations, what does that mean? Well, I built an equation for you right here. Y equals 1.5x. What does that mean? Well, here's one thing that needs to be very clear. This 1.5x, we talked about this when we talked about expressions. 1.5x means what? Yes, it means 1.5 times x. Remember, with multiplication equations, you don't need to use a multiplication symbol. You don't need to use the dot. You don't need to use parentheses. You don't need to use anything. The 1.5 in front of the x is called a coefficient, and that means that's a number you're multiplying by x, or you're multiplying x by. That's the equation. So y equals 1.5x is considered a proportional relationship. Why? Here's why. If I were to say x is 2, what does y equal? 1.5 times x, so 1.5 times 2. If I were to plug 2 into here, if x is 2, 1.5 times 2 is 3. Look familiar? Yeah. Go look over here. Okay. What if x was 6? Okay. Look at right here. Multiply across. What do I multiply by to get 6 to 9? Y equals, did you guess 9? Good. What if x equals 10? Then y equals 15, right? And then what if x equals, let's not say 18 like we did over here. Let's change it up. Let's say x was, say, 15. What does y equal? You got to take the 15 times 1.5. 15 times 1 is 15. And 15 times 0.5, or a half, is 7.5. So 10 plus 7.5 is 17.5. So those are all proportional relationships. Those are all proportional. 2 to 3 is the same as 6 to 9, is the same as 10 to 15, is the same as 15 to 17.5, is the same as 18 to 27, like over here. I can put it 18. If x equals 18, 18 times 1.5 would equal 27, etc. Okay? Now, not all equations, I'm going to show you a couple, not all equations can be considered proportional. Okay, I have a couple here to look at. Okay, take this away. Here we have y equals 4.3 minus x. Okay, not a proportional relationship. And here's why. If you were to take these numbers, let's say these are the x numbers right here, okay, are the x numbers, and these numbers are the y numbers. Oh, let's say x was 2. Is 4.3 minus 2, is it going to be the same every time you put this number in there? 4.3 minus 2 is 2.3. Okay? If x is 6, 4.3 minus 6 gets us a negative number, negative 1.7, right? So it gets really goofy. So that tells you that that's not proportional at all. So we'll cross that one off. Not proportional. How about y equals x squared? Well, if this is x and x is 2, and we square it, that makes 4. Does y equal 4? No, y should equal 3, right, in this? If y was 6, I'm sorry, if x was 6, y should equal 36. No, if it's 6, it should equal 9 if it's in proportion to 2 to 3. So this is not a proportion. Remember, any number you plug in should form a proportion. So let me give you an example of another one with this x squared. Let me do that x. It isn't a proportion, but let me show you why. If I write down the numbers, let's say if x is 1, what does y equal? Then y equals 1, because 1 squared is 1. Okay, if I did that again with two different numbers, so remember that 1 and 1. If x is 1, y would be 1. I'll put it over there. Let's change the numbers. They should be proportional. What if x is 2? If x equals 2 and we square 2, y should equal 4, right? 2 squared is 4, so y would equal 4. 2, is this proportional? No, of course not. 1 times 2 makes 2, but 1 times 2 does not make 4. If I do it like this, right? And or if I go across, if I say 1 times 1 equals 4, well, 2 times 1 certainly doesn't equal 4. So no, x squared certainly is not going to be a proportion. So let's go back and make sure we cross that one off again. Not proportional. How about y equals x plus 124? Well, if x was 1, let's do it over here. If x is 1, 1 plus 124 is 125. What if x was 3? 3 plus 124 is 127. Well, 1 times 3 makes 3, and 125 times 3 certainly doesn't make 127, so no. And the last type of proportional relationship would be
one in graphs. So these are pretty easy. Let's use these examples over here. So if you traveled, and we'll say that this down here represents the number of days. Let's put that on here. The times we gassed up. So the number of days would be, in this example over here, it was 2. So 2 days. If you don't know much about your coordinate plane, this right here is called the x-axis, and this is called the y-axis. So you always do the x-axis first. You go x, comma, y, like this. Okay, that's how you would place points on a coordinate plane. And I'll have another lesson on that eventually. So let's just quickly place those points. So if I go 2, so it's 2 on the x. See, we even had an x here, and we had 3 on the y. So we go 2, 3. Okay, and then we have a 6, 9. So we go 6 days, 9 times filled. And then we had a 10, 15, like so. And then we had an 18, 27, and then I don't have that on here, so we're just going to leave it as it is. We only needed 3 points anyway. But look what we can do here. If we were to connect those 3 points right there, it should form a straight line. Yeah, that should form a straight line, and that's the idea. If it forms a straight line through the points, then it's a proportional relationship. And you can pick other numbers on the line. If you can go 4, 6, look. If you go 4 days, that would be 6 times filled up. Does that make sense? Sure. 2 times 2 is 4. 3 times 2 is 6. So it would have been a 4 to 6 ratio. And so therefore, we have a proportional relationship. That's everything on proportional relationships in tables, equations, and graphs. If you have questions, go ahead and find me and let me know. Go ahead and comment down below. If you have other questions, I can get to you in the comments also. Or if you just have some constructive criticism, we'll say, go ahead and place it there. Or if you just want to say hi, feel free. Good seeing everybody again, even though technically I'm just looking at a camera. But nice of you to see me. All right. Until next time, bye-bye.